So in this video, we're going to be dealing with modified Atwood's machines. In the last video, we dealt with just regular Atwood's machines. Now we're dealing with modified ones. What are modified Atwood's machines, you might ask? Modified Atwood's machines are Atwood's machines that, are essentially, you don't just have two masses on a string and pulley, but you also have another like surface, right, that you're going to be dealing with. So let me draw this right here. So let's say that we had a table, and attached to this table over here was a pulley. So we have a pulley over here. It's a relatively small pulley. Okay. So this pulley that's attached here, there's a string that's going over this pulley, but let me first draw the masses. So this is, say, mass 1 here. It's a box or something. This is mass 1. And then going down here is going to be mass 2. M2. So let's draw the strings now. So we have this string. Let me do that in white. We have this string that's going to go up here, attached here, and then it's going up the pulley, and then it's going to attach. It's not a very good drawing, but that's just how it is, okay? So basically, we have M1, M2. It's going to be moving in this direction, basically, because it's going to be going down. Okay, now we have to deal with the acceleration. I want to find the acceleration of the system here. So let's look at the summation of the forces is equal to the mass times the acceleration. We're dealing with the system, so summation of the forces of the system is equal to the mass of the system times the acceleration of the system. We're dealing with a systems approach to find the acceleration. So here, let's deal with mass 1 first. Let's look at all the forces acting on mass 1. So we are, of course, going to have the normal force, since we are on a surface here. So normal force going up. And then down, we're going to have the force of gravity. So it's just going to be M1G, or the weight force, something like that. So that's that. And then let me just say, for simplicity, actually, let's just add friction to this. Let's say that there was friction as well. Let's say friction. So this direction, this ground is not frictionless. It's not ice or something like that. There's friction. So this is going to be the force of friction. And then in this direction, of course, we're going to have tension. Tension. Whenever you have a string, think about tension, okay? Now let's look at M2. So we, of course, are going to have tension going up. And then M2G down here. That's it. We don't have any horizontal forces because this is just moving up or down. Now let's deal with the system approach. So we need to deal with making stuff positive. So let's just say that this is going to be the positive direction here. And let's do that, okay? So now let's look at the summation of the forces of the system. We have M2G, right? And then the tension is going to cancel because we don't have to worry about that. And then minus the force of friction. The force of friction. Frictional force. These are going to cancel. All right, so this is what we have here. And then, yeah, that's pretty much what we have. And then this is going to be M1 plus M2 times the acceleration of the system. Now, friction is interesting, right? We have M1, we have M2, we know what G is, but what is friction? Friction, there's a formula, it's the fun formula. Friction is equal to mu, the coefficient of friction, times the normal force. Coefficient of friction, let's say that it's given to you in the problem. Okay, so mu is equal to, I don't know, it's going to be something, all right, whatever, right? This is also given, so this is a given. Given. So normal force, however, we have to find. Normal force is equal to M1G in this case. So M1G is equal to normal force. Since the summation of force is equal to mass times acceleration, N minus M1G, if we deal with up being positive, is equal to M1 times A. Of course, the acceleration in this direction is going to be 0. So this whole thing is going to be 0. So that means N is equal to M1G. It's kind of a quick little proof we can do. So N is equal to m1g. So frictional force is equal to mu times m1g. So let's write that. So we have everything in terms of our givens. m2g minus m1g mu, or mu m1g, same thing. Okay, is equal to m1 plus m2 times the acceleration of the system, a-sis, over m, so divide by m1 plus m2, so the acceleration of the system is going to be equal to m2g minus mu times m1g, all divided by m1 plus m2. This is going to be the magnitude of the acceleration, since we're just looking at the positive direction being in this direction. So if we look at each object, they're going to have sign changes. But of course, this is our answer. This is going to be the acceleration of the system. Systemic acceleration. Next, we can deal with an object. So let's say m1. Okay, m1. So the forces, it's only going to be moving and accelerating in this direction. So that's just going to be the summation of the forces is equal to the mass times the acceleration. Forces is equal to tension minus frictional force. M1 a-sis. Frictional force we just found out here is just going to be mu times m1g is equal to m1 times the acceleration of the system. What are we trying to find? We're trying to find tension. Okay, so system. And then if we go up here, it's going to be m1 times the acceleration of the system times the acceleration of the system. So this is going to be plus mu times m1g. Okay, and this is equal to tension. Now, is the acceleration going to be positive? Well, yeah, it is going to be. So because it's going to be accelerating in this direction, and that's going to be, if we look at right as positive, then we are, of course, going to have a positive acceleration. That's why I didn't add a negative anywhere. Okay, but if we were looking at m2, then acceleration, it would be negative because it's going in this direction, which is going to be typically negative. All right, so that's that. This is our answer for tension. Of course, acceleration of the system is this stuff here, so I'll just put an arrow here, so that's that. And this is your answer. Hopefully the modified Atwood's machines aren't too difficult. Really, they aren't, because if you deal with this systemic approach, it shouldn't be hard. And just remember Newton's second law. It's the most important law here. I will be deriving this law in a future video, how this came to be. And so look out for that. Hope you found this video helpful.